So, why the hell did I do this? And it's a journey of discovery for all of us. Here we go. So, as you'll notice, audio electronics, you can basically get away with murder. Some of the stuff you buy, it's amazing that it doesn't shock you. There's a lot of things going for being able to learn electronics with audio, where you have large signals, lots of parts that work at the sort of range of frequencies and voltages, all of that kind of thing. Really, everything is working in your advantage. There are ways to make tones that require very few parts. There are hundreds of, look who it is. Coming in late, I see. Take a seat in the front, please. Yeah, so as I was saying, audio electronics, there's so many things going for you. If you're trying to start even designing stuff, you really don't need to know a whole lot about how it works. A lot of people get started out copying old designs from the 70s or 80s, kind of trying different things, circuit bending stuff even, and just kind of recombining these circuits that they found online. That's why there's a million Moog ladder filters out there. That's why there's a million big muffs out there. Like, it's very easy to get started with audio. And there's a couple of specific things that make it a lot easier for designing than video. First thing is that audio, you can only really hear frequencies up to about 22 kilohertz. Not super important if you don't have like a frame of reference for that. Basically, the thing that you do need to know is that video is maybe like 20 to 30 times faster than that. If I'm probably not doing the math right in my head, but it's at least 10 times faster, which means that there's a bunch of parts that will work for audio that just don't work for video, and you have to buy more expensive parts. And if you're buying more expensive parts and you're starting out and you're breaking stuff and things are emitting smoke, you're going to be wasting a lot. So that's an issue. Also, there's the fact that audio generally, if you have like a 9-volt power supply or a minus 12 to 12 volt power supply, your signal can take up almost that entire range of the signal. And a lot of you have maybe heard of signal to noise ratio, basically being like if you have a switching power supply like the one that I have, it's going to be making like a little hum. Maybe it's high enough of a frequency that you can't hear it, and maybe it's a small enough of a voltage that you can't really tell when there's a lot of signal present and everything's quiet. You know, maybe you're familiar with hearing the noise or the hum if your stereo's on, but you're not playing any music through it. With video, because the signals are so small, they're all 0 to 1 volt. If you have any noise in there, that means that you can see it. And it's a lot harder to get rid of. It's a lot harder to manage noise. It's a lot harder to manage your signal to noise ratio, and it makes it harder to make your signals and all of that kind of stuff stable. So audio electronics are easy, video electronics are hard. Not only with video do you have to consider all of these sort of technical bandwidth, voltage, cost limitations, you also have to have everything synchronized, because as many of you know, with audio, you just you plug a signal in, it makes your speaker vibrate with that signal, and it's basically a one-dimensional signal over time, being that you have the level and you send in signal and it makes waves, and then you can hear those waves. With video, if you try and do that, you're trying to make 2 dimensions of information, right? So everything, in order for it to look like a picture that's not just like scrolling by really fast or just a bunch of chaotic noise, everything has to synchronize correctly. And there's all of these different formats out there, there's all of these different technologies out there that all handle this differently. And so you're constantly going up against, and even, you know, a lot of you are aware, the European standards are different than the American standards, and the South American standards in some countries have their own thing going on. So if somebody has an NES that they bought in the 80s in France and they bring it over here, sometimes it's not going to work correctly with whatever box you made. So long story short, making stuff for video sucks. It's a lot harder than audio, and I kind of came into it thinking, how can we make it easier for people to get access to these things, right? How can we make it easier for people to learn about video? How can we make it people to afford video? Because it is, while it's no longer something where you would have to work for, you know, a large multimedia company in order to have access to these things, so it is a lot more democratic than it used to be. It is still extremely expensive of a hobby. It makes it very difficult for people who are starting out to be able to get anything, you know, useful out of it. Maybe they can make and do some quilting or whatever, but it's going to be it gets repetitive quickly, and so the temptation is, well, I'll just keep buying modules until something that I make looks cool, right? So I kind of came into this in terms of, first of all, from my own financial limitations, being like, all right, what can I do with the skills that I've got? How can I make it easier for people for myself to afford these things, for other people to afford these things, and also to be able to buy gear that maybe sits in your studio, where if you're bringing it out to let other people use it, you know, either at a museum, at a party, at a school, that if something goes wrong, it's not like, oh no, my oscillator that LCX just discontinued had a beer spilled on it, and now I'm never going to have that thing again. So these were all considerations as I was getting into the process of starting my video journey. A big thing that Carly and I like to do as the knob fondlers is we bring these video synthesizers to events. There's sort of a story that started all of this. We got invited by a friend of ours who knew that we did this sort of video synthesis to come to this event in the forest up in Northern California, Mendocino. It's very pretty. A lot of kind of psychedelic ravey stuff going on, people doing some very compelling liquid lights and that sort of thing at the main stage. And we had our own like kind of side stage thing, and my thought was like, okay, well, I'm gonna bring a projector screen and a projector, and I'm going to lug around this battery, and I'm gonna bring it to the middle of the forest somewhere and have it be like this secret thing where you're like wandering through the forest late at night and you stumble across this like magical, like, you know, this thing you've never seen before. And obviously, possibly people are in the state of mind where they would appreciate something like that. So quickly I learned that I was not, after, you know, working this event and, you know, sleeping in a tent for a couple days, I'm like, I'm not carrying that battery anywhere. I had a radio flyer even. I'm like, I can't lug that thing up the hill. This thing's gonna kill me. Like, let's just kind of wander around and see what else is going on here. So we quickly come up across a stage where there's a lot of people and there's a screen and they're projecting Rick and Morty, right? And I'm like, well, their art sucks. Maybe they would appreciate some good art at their stage. And so I walk up to the DJ who, you know, it wasn't like super exclusive or whatever, he's just right there. I'm like, hey, we have this cool like video generator that we'd like to plug into your projector. Can we do this? And he's like, I am too high to talk to you right now. I can barely handle DJing. Like, this language is like, it's difficult to even like bring myself down to this dimension. Like, go find somebody else for a little while. So we go find some people who it looks like it's their camp, and we go like, hey, we have this cool video art. We noticed that you're just projecting something from your computer. Can we put this on your projector? And they're like, we're too high to talk to you right now. I don't even like, is this my camp? I don't know. It could be, who knows? Like, I'll end up there eventually. So after a while, we're kind of talking to each other and we're like, so what you're telling me is that we could have just thrown our art on their projector and nobody would have known the difference? And maybe they would have been like, hey, remember when our art was like actually really good for a minute? So we have started essentially going to events. We don't usually take over people's projectors, but it turns out that you can find outlets everywhere at these things. And if you bring your own projector screen, you know, something lightweight, we found something that's like less than 10 pounds. We have a little LED projector, and I have usually a skiff with just the visual cortex, 2 oscillators, and another kind of module to mix them up and give it a little more variety. We'll find people's generators with a splitter on them and just plug our projector in and put the screen there, and then all of a sudden there's video art there, right? And so You don't have to ask anybody if you just do it. They usually just assume that you were supposed to be doing it. And in this process, we've had a lot, like the results, the general feedback has been so positive because it's really rare for, especially as an adult, for you to run across something that you just don't understand, you know? And people come up and they're like, what is this? And I'm like, here, touch that knob. And then we walk away for a little while, and all of a sudden, there'll be like 3 or 4 people who have never touched this thing. I believe I have an example. 3 or 4 people who have never touched this thing, making really cool art all on their own. And because like it's visual, if something goes wrong, you know, maybe the screen turns white or it starts flickering or something, it's not gonna end the party. It's not like with audio gear where it's so like dangerous to give a newbie something like that kind of power, you know, where either it can make a high-pitched squeak or a bunch of clicking, or it could be silent and then everybody's like waiting to dance. Like this is so unintimidating, and the feedback is immediate because you turn the knob and you just see, oh, the color changed or the spacing of these lines changed or whatever. And so we've had a lot of success with this thing, and yet I'm bringing my LZX system to these desert parties where anything could fucking happen to it and I would be screwed, you know? And so a large part of the motivation behind me starting to develop my own modules was like, I want to have something where if like it's small enough that I can bring a whole bunch of these things to this place and possibly even leave it alone for a while, and hypothetically, if somebody did end up stealing it, like good for them, you know? Like it wouldn't be, I would be out a couple $100, but you know, it wouldn't be like irreplaceable, you know? So that's another part of the motivation. That's part of making it more accessible. Some of the people that I've shown these things to have been like, where can I get this? And I'm like, well, you got to spend like $1,000 or $2,000. And they're like, cool, give me your email and I'll buy one from you, right? So it's not, like a lot of people, video has this weird quality where it's like very difficult to monetize, I find. Like most of my customers for audio, like they're either artists, they do sound design, they do game design. With video, it's like, it's such a weird kind of impractical thing that like, unless you're doing a lot of gallery work or working in a museum or something like that, that's like a very, the market is small, and the people who make money doing it are even smaller. They're like unicorns basically. So having, for a lot of people, the attractive thing about the video is not like, oh, I'm gonna be the next big video artist. It's like, this is so pleasing to me, I wanna have this in my home and to be able to do this whenever I want. So, I don't know why I was talking to you about all of that, but that's about making it more accessible, bringing this to places where people are able to discover this new thing, try it out for their own, and they get to, you know, they participate in the creation of the art in this way where they would never, you know, these things are so like, these events can be so elitist where it's like, oh, you have to know the producer and the this and that in order to get on, to be able to play. And it's like, now just anybody can be making art. And I feel like that's valuable. Doing it yourself is obviously the other way to make these kinds of things more accessible. Obviously, Philip has been doing amazing work with DIY modules and making them easier for people to get their hands on these kinds of technologies. So that was a big part of my motivation towards doing this, is like, well, there's already all of these great DIY modules that are being made for video. What can I possibly add to make it a little bit more exciting? What isn't being explored? What can be, you know, looked at through a new perspective? Yeah, so there was, there are some downsides to DIY, and I believe, no, I didn't talk about that. Well, there's some downsides to DIY for video, and basically a big part of it is that the parts that are easy for people to build with, basically being the through-hole stuff that we've been handling here, a lot of it doesn't work at the speeds that video works at, and if it does, it's like way more expensive than the surface mount equivalent. There's a lot of issues with I guess, I'm gonna stop that thought. I don't know where I'm going with that. Essentially, I started out with these ideas for like standalone DIY synths where I was like, oh, it would be really cool if you just had like a bunch of logic gates and the module, because they all work really fast, the module you would make the visuals by recombining the logic gates and kind of like plugging VGA in and out of it and like doing all this complicated stuff. And I quickly came across something which Lars essentially was like, it's going to be cool by itself, but nobody's going to be able to use it in like the environment of video gear that exists. And so it's just going to be this kind of thing that is like an oddity instead of like a useful way for people to make art with it. And so there were reasons where I was tempted to start either a new format or a new sort of like standalone device that would be patchable but wouldn't necessarily reinvent the wheel. And there were reasons that were attractive to me to stay within the LZX format and universe and have my devices be LZX compatible, and that's ended up being the direction I went with. So doing it DIY became much more difficult at that point because Lars has pretty strict standards about what he's willing to accept as LZX compatible. I'll talk a little more about that later. So one of the ways I was thinking about doing this was essentially making modules that would work both for audio and video, and thinking that that would make it easier for both for me to sell to two different markets, and therefore to justify the cost of producing something that works with video. Because at the beginning of this, another consideration was like, how do I make a video module without going broke myself? You know, like I had no idea how many people would want this thing. I had no idea how big the market was. And I'm like, whatever I'm doing, it's going to be experimental. So I made a module called Anna. And Anna is a logic module that works with like voltages. So it's not just gates. It also, if you put smooth things into it, you'll get smooth stuff out. And I just one day was like, let's see what happens when I plug video into it. And it ended up, it had some nice results. It is by no means LZX compatible. It does not use the fancy op amps that are usually required for video. And I do not necessarily advertise it as like being a video module, but I use it a lot for my own video stuff, even though it's a little rough around the edges. And one of the big reasons for that was basically if I had to make something that worked for audio and for video, that no matter what, there was always this frustration between like, if I have a knob and it has to accommodate all of these different voltage ranges, then I'm either going to hamstring the operation of the device for video, or I'm hamstringing it for audio. And in that way, and if I do it for both, then nobody's happy. So at a certain point, I was basically like, this is an audio module. I'll use it for video. It does useful stuff for video, but I'm not going to sit there and go like, okay, it has to do audio and then have like a bunch of switches in the back that'll switch it to video or something like that. I have dreams of one day making a video specific version for it that you can put a camera through and all of that kind of stuff. But for now, I was satisfied that I had at least made something that did useful stuff for me with video. After that, I had worked on Tree, and Tree I intentionally made to work with video. I wouldn't say it's LZX compatible because there are certain limitations of the switching hardware and all of that kind of stuff, but I made sure all of the clocks would work with either a video signal that's going from 0 to 1, or with an audio signal that you could like run it with a sine wave that goes from like -10 to 10 volts, or you could run it with a video clock that's 0 to 1 and it's going like megahertz speed or whatever. And I think that was sort of the thing that helped me get halfway between audio and video, which was that it didn't work with voltages at all. Everything was just clock inputs. And so I could basically set a threshold where everything would work at like 0.5 volts. So if you're running a 0 to 5 volt clock into there, it'll still work. I'm sorry if this is like really boring, like minute details, but for me, I found that like the best way for me to make something that worked for both audio and video was something that purely was clock oriented. And the nice thing about Tree is that it also it does analog switching. So I can have the input clocks all run at video rate, And then if you use it with the video buffered multiple, in order to kind of like fix the weird impedance stuff that happens with bidirectional switches, you can actually use it to switch video. And it looks really nice even when you don't, because you can see like these kind of squares over here. The three-dimensional effect is all from the slew that kind of comes from the weird impedance bullshit that happens when you don't use a buffered multiple. It looks really nice, personally. That's running video, yeah. In fact, I might show you a little bit of Tree doing its magic over here. Let's see. I'll just do some of this. So I'm gonna go ahead and unpatch some stuff. Now, oh my gosh, who knew? All right. So I'm gonna do the reset and the clack. All right, we getting some stuff? Nope. Like that. How's that? All right. Very nice. Thank you. Okay. This one's the clock. So, tree. All right. So we've got some funky lines over here. What I have is a prismatic ray over here that is providing a clock to tree. You can see it's running like a horizontal line kind of thing. A cool feature of tree is that, okay, I'm just really quickly gonna say what a sequential switch does before I start like explaining to you how this sequentially switches. So if you have a module like, let's say, prismatic ray, where you have like a little knob and you turn it and it clicks, basically what that's doing is it's a electrical switch that takes one thing and it selects which connection out of a range of like 4 or 8 or something like that is connected to this one other connection at the bottom. The useful thing about this is you can switch the range of your oscillator, you can switch the octave of your oscillator, you can switch its waveform, you can switch the type of your filter, and it's the kind of thing that doesn't necessarily lend itself to either a just pure on-off switch or a knob. So a sequential switch is kind of like that, except that it is it works purely with electrical signals. So if you send a sequential switch a clock, like if I was to slow this down, the sequential switch will more or less, it's doing some funky stuff. The sequential switch will, all right, you can see this LED over here. Whichever one of these jacks is next to that LED that's currently lit up is electronically connected to this common jack, sort of as if it was like a rotary switch that you were like turning manually, but instead this one just gets a clock pulse and it goes like, all right, I'm gonna connect to the next thing now. The cool thing about doing this at video rate is that you can run a video oscillator in, right? And so we're getting these bars just based on the sort of gate signal that is also able to be generated by this. We can get some cool shapes by running some FM into the oscillator, right? And so we're getting these nice kind of weird three-dimensional shapes from that. But something I can also do, so I could, the prismatic ray is clocking tree, and what? No, sorry. So the prismatic ray is clocking tree, and then tree is generating a gate signal that has this sort of weird impedance, which is giving it the soft edges at video rate.
And then you're running that into?
And then I'm running that into the visual cortex. So I could do this just like black and white, just so it's a little easier to see what's going on. You can see we're getting some nice like smooth lines out of it. what we can also do is we can go out of this common jack, and then let's say I had like 8 oscillators I wanted to plug in, or even just like, we'll just do 4, right? So we've got 1, 2, grab this guy, 3, 4. And now if I want, I can just kind of slow this guy down, and we should have sort of like 4 sections where I am now able to run 4 different oscillators into here. That one's a little glitchy, it seems, but yeah. So
Do those only take oscillators, or can you run audio?
no, you could run in audio, you can run in ramps. I could maybe take this guy.
So anything that generates like some kind of
Yeah, exactly. This is designed to work both for audio or for video. So if you can use it for like sequences, you can use it for LFOs, you can use it for you can also send one thing to 8 places with this because it's bidirectional, right? And so in this way, maybe I'll take, this guy does not seem to be getting along, so maybe I'll go for this other oscillator, do like a horizontal line. Yeah, so you can see here we are almost like candy striping between 4 different video signals, and we're able to control that. Are you still getting audio? All right. We're able to control that with an oscillator. So now I'm increasing the speed of my oscillator, decreasing the speed of my oscillator, and then frequency modulating the oscillator, and we're able to sort of bend between these. And you can see, like, if I change one of these signals, it doesn't change the other ones. If I turn this guy up, maybe, and then that one up, and it might be a little bit better if I buffer the output, because it'll fix our impedance stuff. Yeah, get it nice and smooth. So now we've got a whole bunch of funky things going in. Yeah, so that's that.
Where's the buffer?
The buffer is on bridge over here. I'm sorry, that's off screen, yeah. So bridge can work as a buffered multiple, and I'm currently using it like that. So yeah, I mean, this is about as close as I was able to get to a module that works both for audio and for video. And it's something that I feel pretty confident about, being like, yep, you can run in video really quickly, and it'll be able to do some funky stuff with it. Another nice thing about this module in particular is that it has all these weird modulation inputs, so you can plug something into shift by 2, and it will let you kind of shift like the selection of the video signals with another signal. If you have 4 of these things going in, you can address it with binary. So you could use the Castle digital or analog to digital converter in order to address this. Not currently tested, but I'm fairly confident about that. And then we'll have to test that later, maybe. Yeah, so.
Hey, Eli, question for you.
Yeah, what's up?
Would you call this more of a video lasagna or a video layer cake? Because I'm really liking the layers there in this guy.
A video layer or lasagna?
Like a cake or a lasagna? So it's like you've got all the
Oh, yeah, sure. Huh. Well, that's an important question, actually. The question is whether this is more of a video cake or a lasagna. And yeah, I mean, the thing is that, like, how many cakes have that many layers? And so I feel more like this is like the flow of some video soup or something like that. Or maybe maybe we're making like video asphalt or something like that. What's up?
Eli,
Yeah, so it's 8 inputs, and it's bidirectional, like I said. So if you use the buffer going in, you can send one thing to 8 places. So yeah. Thank you, sir. I have not tried clocking it with a camera feed, but I use a comparator circuit that I have. Well, actually, no, I use a different comparator circuit. I'm pretty sure it would work. I'm happy to do some experiments with it later so we can come up with exactly how useful it would be with an actual video input signal. I don't usually work with video input. I'm interested in just like the pure synthesis and stuff like that, but I realized that it's important to have like specs on exactly what it would work with. So yeah, colors, agreed. We've got some colors here. I'm obviously a big fan of colors. Let's see. Why is that white bar? What's feeding that white bar? Oh, I guess that's just the blank. Okay. Any more questions on tree before I go over some other slides and things of that nature? Just while we've got tree in the mix.
Are you gonna be here tomorrow?
Yeah, I'll be here tomorrow. And
Got a tree in my desk.
oh yeah, I'm happy to show you some tricks of the trade. I guess another cool thing to do with tree is to run a ramp into one of these shift inputs, and so you're able to get kind of an inverted selection in that specific zone of the image. You can see how it kind of like scrambles the order of things in a really pleasant way. Yeah. All right, so back to the slides. What do I have next? All right, so after tree, I had some ideas for a video synthesizer that were related to my work with the Raspberry Pi. I do prop work, and in this particular instance, I was using the Pi to drive these old monitors, and you're able to do it, it looks like it's just text, but it's actually able to display images because the Pi has an alternate display mode where you're able to use the pin outputs as VGA, but it does it in binary. So it gives you 6 bits of color for each color channel. And I'm sorry if this is a lot of technical information, but basically I was like grabbing a video output from the little pins that are like on some of your Raspberry Pis, and it comes out as binary already. And so if you recombine that using resistors, you can just plug it into a VGA, that's fine. Or you could take those bits in the inside of the, before it hits the sort of resistor digital to analog converter that would turn it into VGA that looks normal, and you could hit it with like logic, or you could scramble the order of the bits, or you could do something like that. And I was like, it would be really cool if I had this device that worked with a Raspberry Pi, and it had some kind of digital, either video player or a synthesis algorithm or something like that, that could have maybe voltage control and stuff of that nature built into the Pi, which is then sending out all of its video data in binary, and then you're doing weird stuff in the analog realm with that as well. And I've had this idea that that would be a really cheap way to give people a powerful DIY synthesizer. And of course you can see here, it kind of looked like shit. This was very breadboard kind of over the course of an afternoon. I had more or less identified some things that could work well with it and work poorly. And you can see these bars that are, opening and closing was basically like the first step that I took towards making this oscillator that I made, which was using a 40106 based oscillator. It's the cheapest, easiest oscillator that every, punk kid who does their circuit bending stuff learns first. This is the easiest way to make a tone. It has 3 parts. You can put all kinds of weird stuff in the middle there and turn it into some other bizarre noise-making device, but this is like the easiest way to make an oscillator. And I was like, it would be really punk if I made this oscillator using the first thing that everybody learns how to do, but I do it with, do it as a video. and then have your oscillators work with video. And so my plan, as I was saying, was to use only CMOS and transistors. It works really fast, and they're really cheap. You can get all the parts for like less than 50 cents. Op amps are where you start to run into the cost of a video module. Op amps and VCAs and stuff like that, they're all like $4 to $10, and it adds up really, really quickly. So I wanted to make this through-hole, open source DIY thing that I could like teach, you know, like DIY workshops similar to what's going on here, where people would make their own like VCO. It would all be like in this crazy kind of like punk, unfiltered kind of way. And I wanted it to work on unipolar power so that you didn't have to use the fancy Eurorack power that's adds, you know, $100 to $200 to your first video synth. You can just get a $5 laptop power supply, plug it in, have a bunch of weird video oscillators doing this crazy stuff, and get started on a video synth for less than like $100 hypothetically. Of course, well, this was my first design, and I think if I have the mouse here, so yeah, I mean, I ended up using a lot of the comparator circuitry that I used from Tree, so I already kind of had a head start with that. My frequency modulation had an attenuverter, which was basically like a pot that sent the frequency modulation signal either to one transistor, which would lower the frequency, or to this other transistor, which would raise the frequency. And I used a bunch of, it was literally like 3 chips and a voltage regulator and a bunch of transistors. And it actually looked okay. You know, it had some interesting, the stability was fairly good. You can see there was some noise on the lines, but that was basically because I was working with a breadboard, and so kind of going on from there, it got better once I made it into an actual circuit board. It also had these really cool like nonlinear qualities to it. So this was the frequency modulation up here, and you can see that it actually cuts out the signal, so it gives you like negative space while you're also bending the lines. It also has this cool like little chopping quality to it, where the lines will sort of like bend into the area where they're being cut out. And then I put an XOR chip in the feedback loop for the oscillator, and it let me like reverse the lines. So this was like more or less like this shape with another oscillator going into the flip input, and it gave me these really cool like checkered kind of shapes that all of this was really cheap to make, you know, and it was giving me compelling results. But there were some issues with that. I couldn't get a full range triangle wave because the 40106 has like a certain range that it's preset to work with. So I had to eventually switch that to my own chip. The output impedance was all over the place because I was just using a resistor divider to go from 5 volts to 1 volt. And as Lars pointed out, I needed to use an op amp in order to buffer it. And I already at that point was running into issues with my original design where I'm like, no op amps. It's like, well, now I am using op amps on the output, but that's the only place I'm using them. The FM circuit had an attenuator, which was really frustrating to work with and unpredictable. The sync distribution was really weird because if any of you came up to me at one of the trade shows where I was showing this and flipped one of the switches, it was like, oh, well, no, actually you need to repatch it in order to do that, and that was a pain in the ass to explain to anybody. And also it was really noisy. So this was the first version of the board. You can see 3 chips. I was using only pots and transistors. Other than that, the little voltage regulator. Not a lot of power filtering. You can see here I have 2 of these big these big capacitors. Down here I have 3 of them just at the bottom of the board, just as like extra power filtering. So this is the board as it is now. It's 4 layers, and it's the first 4-layer design I've ever done. So it's like, this is by far the most complicated thing I've ever designed. All of these, like this entire section of the circuit now fits into like this area. I had to add a bunch more protection circuitry. so that if you plugged audio into the video inputs accidentally, you didn't fry your oscillator. I had to add a sync separator, which is sort of like how LZX now handles sync, is you have an RCA cable across the back, which basically sends like a blank video signal, and then you're able to grab the sync, the horizontal and vertical sync out of there. So I have like fancier switches to handle that. The FM circuitry has a completely discrete attenuverter, which was like kind of insane to work with because for reasons why I won't bore you with, but maybe I can show you a bit about how the new module works, if that would be possible. And yeah, I'll do some patching here to get this guy plugged in. Obviously, we've got to do it into the colorize input because that's my favorite. Yeah, so you can see here, this is the oscillator that I've been spending my whole life working on. This is it was originally called the PF oscillator. It turned out that that's a joke that not everybody understands. PFR stands for punk fucking rock. And it was because I had this like image of it being this thing that, you know, you could build using parts you scavenged from a TV or you know, a radio on the side of the road or something like that. It's no longer that thing. So in the future, the name will be Ruins. You can see the anarchy symbols and stuff like that. It's a little, I wonder if I can focus this just a tiny bit. Yeah. You can see the anarchy symbol right there.
Little Nordic rune symbol?
Yeah, well, sort of. It sort of did take on like an occult sort of imagery, which a lot of my other modules have similarly. Like this is a Vesica Pisces, and then there's Tree, not really so much, but Portal, obviously. I'm wearing a shirt for Portal, one of my audio modules, and it's got like evil shit all over it. So, as well as like obviously the image for my company is a like, Goetia style visual. So, yeah, the occult imagery certainly worked its way in there, but the actual labeling and all of that sort of thing, because nothing worked precisely the way it was supposed to, I tried to avoid like actual word-based labels because I wanted it to be like, yeah, the anarchy input like changes this knob that is also the anarchy knob, but it's not really like frequency modulation the way that you're getting on a prismatic array where it works exactly the way that you expect it to. So as an example, we can plug, you can see here, we've got our ramp going in. I just have a diamond going in, and we are getting frequency modulation. It's giving you those cutouts like I mentioned, and you can see like for being based on such cheap technology, it is still like really stable, comparatively speaking, especially to the first version of my oscillator. I could show you, I guess, some of these in comparison at some point, but you can see here, we got our frequency, and it'll do some weird stuff. And you know, that's obviously a part of the allure. Like, if you want something, if you want the Rolls Royce, you get the prismatic ray. If you want the soccer mom van, you get Ruins. You know, it'll get the kids to band practice. You know.
That's the new name.
Yeah, exactly. This mom van. Yeah. So you see here we've got this. I could also run some of our other oscillators, and of course, because I built this by hand and it's a very complex build, not all of them work exactly the same way, but hopefully this will at least give you an idea of how it all is. You can see, you know, in the amount of space, it's the same HP footprint as a prismatic ray, and it is also, you know, probably going to be comparable, if not less expensive than a prismatic ray. But you're getting 4 oscillators. Let's see. It's doing some weird stuff. Mix. All right. There we go. Okay. So we got one oscillator doing these bars, the other one doing those faster bars. I could do one that's horizontal. Oh no, that doesn't seem to be. There we go. All right, doing some. No? It's possible that I broke one of these too. But already you can see, like, I have kind of come across a bug where if one of the oscillators is switching, like, I don't know if you can see, like, this bar here is also bending that green bar in the other section. And people tell me that they like it, but I would prefer if you were doing that on purpose, you know? But, yeah, I mean, it's hackerish and weird, but that is definitely the intention, especially since it is capable of doing a lot of strange things with its modulation. So if I'll run a prismatic ray into the flip for this oscillator, and you can see there's kind of like sections in that red oscillator that are now standing still. I could also, I guess, run a ramp into the, there's already a ramp going into the FM, so we can get some really cool kind of like sections where it's more active than others, and you like that kind of thing, right? That's what PFR Slater, now called Ruins, is all about. Getting these bizarre points where it starts doing things that aren't really typical of other video oscillators. I'm a big fan of that and getting some checkerboards. It's cool too because if I was to say run a ramp into there, you actually have an oscillator that's giving you both horizontal and vertical lines, which is not typical of video rate oscillators. You can see kind of when the diamond reaches the point where the oscillator intersects with it, it kind of like creates this stripe across the rest of the image. That does some really funky stuff. Another cool thing about Ruins is that it can work as a filter. So here we have our diamond coming in, and I'm smoothing it now to give it the sort of smoothed effect. It can also, there's the square output, and this works as sort of like a trigger delay kind of thing. So you can see the diamond is sort of moving to the right in space as we lower the frequency. The flip inputs still work as you're doing this. So you can be like inverting your signal and also doing trigger delay stuff and also frequency modulating it. So let's try running some FM into this. Maybe as a horizontal line. And yeah, so you can see here, I'm getting some weird stuff out of it. And I think you can imagine like having 4 of these to interconnect would be pretty useful. In fact, why am I using prismatic ray at all for this? Grab one of these, run it into the FM. Got some lines going on here. Take this guy, do some of that, and then could be taking this out of here and doing some of this. Oh yeah, well, the flip and all of that kind of stuff also works on the triangle output, so can get some fairly strange. I think this oscillator doesn't actually work. It happens sometimes in building prototypes. I am looking forward to having somebody else build at least the prototypes for me because it's been kind of tough doing it all by hand. Yeah.
Can you trigger any of these with like LFO or audio or anything like that?
Yeah. Let's see. I mean, it has to be the right range. So I'll just run the prismatic ray in. You can see we're getting some voltage controlled filtering. If I take this out, probably out of the flip too. What's going on here? Yeah, we're getting some frequency modulation of the line spacing. Because if I slow that down, it might be a little easier to really tell. Yeah, so it'll take like control voltage range stuff. Obviously, everything's designed for 0 to 1 volt, so it's got to more or less stay in that range. This will run as an LFO as well, but I'm not really happy with its performance as an LFO, so I've got to work on that a little bit more. It kind of like either goes really fast or it sort of stops cycling, but it can go about that slow. So ideally, I'd like it to go a little slower than that. Yeah, it's kind of funny at this range because it just gives it a little like hiccup almost. Yeah, so that's ruined so far. It's getting there. It's got a couple of small things I want to improve. Obviously, I could keep going on this forever with things that could be improved, but you know, I feel like I've already started using op amps. So if I'm gonna make it fancy, you know, I've got to at least have it be like make the LFO range and the knob range and all of that like feel good. Because at the moment, like for example, if I was to do like a horizontal line, and then you run the FM into here, like the FM in this direction looks fine. But if you start going in that direction, it can cut out actually like over here. And because my attenuverter is discrete, it's actually like kind of tough to control that. So yeah, little tweaks like that. I feel like another revision or two of little tweaks will get it to a point where I'm happy enough to release it. Yeah, any questions before we, yeah, what's up?
So one of the things I've noticed with VFR oscillators, I saw it at Synth class
Uh-huh.
a while ago, is that the tearing that you were talking about, the FM tearing,
Yeah.
is very distinctive about that.
Uh-huh.
Is that something that you're going to like remove with your revisions, or are you going to keep it or make a switch?
No, I'm pretty happy with how FM works on this right now. In fact, I was working on some like alternate forms of FM that might also happen with this, and I think that those are going to end up in another module more or less. I would like there to be more room for the FM turns in before it turns off, but at the moment, like I'm fairly happy with how the FM looks. I'd just like to sort of make it so that the knobs give you a wider usable range, more or less. Yeah, well, you know, the mom van is like pretty, you know, that's what punk really is. It's like making that van last forever. Yeah, exactly. I don't know how much anarchy you can fit in a sports car. Not that much. Fit that in a mom van, you can take a whole ton of that stuff. Yeah, no, the FM behavior is probably my favorite thing about this oscillator. And what is even more my favorite thing about it is that normally for FM in an oscillator, you have to use a VCA, and the video rate VCAs are like $4 or $5 maybe, like, and you know, it doesn't sound like a lot, but if you have 4 of them, and then you have to consider also like usually the rule of thumb for like releasing a module is the cost of it. The end price is going to be the cost that it cost you to produce it times 5. So like if I add $20 to this device, then the price of the device, then that's $100 on the cost, right? So if I'm keeping the cost down, finding cheap solutions is the goal, and the FM circuit in this usually literally uses 2 diodes per channel. It's 10 cents worth of parts. So I'm really happy with how it works, especially given the price difference in how it is. It looks really, I actually quite like the way that it creates negative space too, especially when I have something like scrolling and then it's cutting portions out of the wave, and making things like diagonal and weird. Like it looks really nice. So that's something I'm definitely keeping. You had a question, Ed? Yeah.
So it's four independent oscillators.
Yes.
And you can independently select the frequency ranges,
Uh-huh.
right?
Yes.
How does
Yeah.
that,
What's up?
trying to,
You don't like that?
no, I'm into, I'm intrigued by that.
Yeah.
How do you fit that all in such a small?
It's literally like 4 different versions of the circuit. Each one of these switches is a dual channel switch, so you're able to do it with.
Oh, I couldn't see the switches.
Yeah, there's little switches down here, and you can see like horizontal bar, vertical bar, and then the slope is more or less like the LFO. Is this thing?
Is there wave shapers on those? Or?
Not really. There's basically the triangle wave, which is not really a triangle wave. It's just I call it the smooth output because it gives you sort of like, a little bit of smoothness to the shape. And then the square wave, which is not the squarest of square waves, but it gives you a little bit more harder of a shape. So I guess like something that I'd like to ask you folks while I have everybody's attention is this behavior with the oscillator, right? You see how I have this diamond shape, it's looking nice and smooth, and then as I turn this oscillator up, it starts to get kind of jagged and weird. Like that. You see how the lines are kind of all bent, the oscillators are all interacting with each other? How does that make you feel? Yeah? You like that? Yeah? A lionfish. Yeah, I get a lot of fish shapes out of this module. Just because of like the a grouper, exactly. It's like a grouper or like a beta fish almost. Yeah, it's very sharp, one of the kind of more jawy fishes. All right, so you guys like that? Okay, does anybody, with color, okay, color. Whoa, why is it not color? Okay, there, color. No? WTF. All right, and it needs to be CMY because, All right. There are 2 possibilities. The first possibility is that because I'm using some 4-channel chips, like the comparator that's a part of the feedback loop is 4 channels, and sometimes these chips have what's called crosstalk, where essentially the electrical components being so close to each other makes it so that magnetic waves from one channel, even though they're not like technically electrically connected, can start talking to the other channel. Either that or current being drawn by one channel can cause the other channel to... Yeah, exactly, yeah, the rails will dip a little bit. It's possible that I am driving the inputs to the chip with too much current, and that if I'm pushing a bunch of current in one channel, it makes it so that the other channels are affected. So there's a couple of possibilities, and my solutions for coming up with this pretty much... The solution requires a somewhat drastic redesign where I would essentially have 4 single channel chips that have no crosstalk whatsoever because they're all on completely separate ICs. Either that or possibly tweaking some of the values for the circuits that are driving these ICs would help reduce the crosstalk. But I mean, if people like it, then I'm not going to fix it. Is there anyone who does not like this? Is there anyone who would like me to get rid of the crosstalk?
No, but I like that filtering.
Yeah, the filtering? I'm using the smooth shape. In fact, something that's really nice that I like to do with this is I'll take one of the output from one oscillator and I'll put it into another oscillator as a filter, and then you can see if we put in the right range, we get some funky it needs a little bit thicker of a line to actually get there, but you can see we're getting some nice kind of like thickening of the lines, and then this would be the trigger delay one, so we can get some weird kind of shapes out of that. You get them to all kind of smoosh together a little bit, like that. Yeah, like that. So you're actually getting the lines to kind of like morph back into the ramp that they came from. That kind of stuff. You can see that's the thing though. It's like it makes such nice smooth lines when it's working normally that like I feel like being able to do that intentionally would be better than it just happening no matter what you do. You know what I'm saying? Okay, that's good to know. Well, okay, I'm gonna see what I can do to reduce the crosstalk without completely redesigning the. Leave it. Okay. Well, you'll just have to buy more than one if you don't want it to have crosstalk. Cool. Any other questions before I more or less finish the talk? Oh yeah. I mean, you can send me money if you want. I don't know when the module's coming out. So if I don't have to fix the crosstalk, it could probably come out pretty soon. But yeah, I'm sure some people in this room will be beta testing the functionality and helping me with all of that. This was like one of maybe the second or third design that required me not to cut any traces or do any weird wiring along the back. So it is more or less ready to go. I am probably going to upgrade the voltage regulator to the fancy one that Lars uses just because I do notice when there is a switching IC with a bunch of noise on it, like I notice the noise sometimes. So I feel like that's one of the things it makes sense to spend a little more money on. And yeah, so I guess, yeah. Yeah, it's RCA sync from the back, exactly. I was considering making it so that you could like plug the like a signal in and then the signal would like FM all of the oscillators or something like that, but I don't know, maybe like as a different version of it, like it'd be nice to have it be like some kind of standalone device too where it could also like glitch out some video because we've run a camera through it and it definitely does some interesting stuff, so what's up?
Can you make it full screen and show us some of the weird shit?
I don't know if that would be okay, Jake. All right. I like that actually with the like little duplication. All right, so let's see. I could probably do something fun with this ramp if I were to plug it in over here. The color scheme? You kidding me? All right. I'll do the key. I'm not going to do the key. Let's see if I do it like this and then like that. And then the threshold being lower. There we go. Solarize instead of colorize. Okay. Is that with the green input or the red input? It turns out I don't actually know anything about video synthesis. Yeah. Well, I mean, here's the black lines because, you know, everybody wants me to make stuff in black all the time. Here's the trigger delay. If we were to maybe, something I do really like with this is running a ramp into, or rather running prismatic ray into the flip or the FM or something like that, and then PFR ruins becomes almost like a distortion for prismatic ray. So you can see this is the wave coming from prismatic ray, and then this would be the frequency. And what are we doing here? I guess this would be the flip and the FM. Yeah, getting some weird stuff there. You could also, I guess, run one thing into the filter, and then the other one like that. I mean, obviously, you can use this as a filter for the prismatic ray. This is always sort of how I pictured using the device instead of as like a replacement for the prismatic ray, which obviously it does not do a lot of the things that the prismatic ray does, as sort of like a utility where you're able to really easily get like a range of modulation for the prismatic ray, or other things of that nature. Yeah. Yeah, we're kind of, looking at a setting Arizona sun here. Maybe color would be good for that. I don't know. Get a little bit of wildfire coming from California. Yeah. Obviously, I'll be around, so if any of you want to patch this thing over the next couple of days, that is certainly possible. This is... Let's run this into the FM. Yeah. Cycle. And then we've got prismatic ray doing some FM. So this is kind of what I was talking about with the points where it like cuts out and stuff like that. Like if I get some weird stuff like that. And this is me just changing the slider value. Yeah, it's almost like a weird kind of like a saw blade or something like that. When it goes like that. Yeah. Okay. I have one last slide to show, and then I think we can call it a day. So we already talked about. Oh yeah, another issue. I don't know if I can make this thing DIY. It's already super complicated. Having a 4-layer board, yeah. So I'm probably gonna make like a single channel version of it that's DIY. Maybe runs at like slightly worse specs. But I'm still committed to making some DIY video stuff. I'm still committed to making these more accessible. Even if that means you've got to buy the already assembled module that's just a more affordable sort of utility than maybe the stuff that's offered by LZX, simply because their stuff has to work perfectly and mine doesn't. That it would be a possibility. But I wanted to bring a prototype for the new FM behavior that I discovered with this circuit. I wasn't able to get it finished in time, but this is more or less what it looks like. This is just a diamond going into a static oscillator, and I'm changing a couple of the FM attenuators. This is all on a breadboard, so it is extremely stable for the sort of like noise and stuff like that that's going on. And one thing about it was that changing various resistors within the circuit drastically changed how the FM interacted with it, and that I wanted to, obviously having like 4 of those in the same oscillator would make it huge. So I'm thinking you can see like some of the wires get disconnected for a minute, but having a single channel of this where you would have more than one FM input, which is something I've always wanted on a video oscillator, and then having like these attenuverters that have like more than one dial on them to let you really like micromanage how the oscillator is affected by an external input, and all of this crazy nonlinear stuff that's happening. Like in a moment it's gonna like that. This I've never gotten anything like this out of a video synth before. And it's so stable. Like even though it's nonlinear and glitchy, it's extremely, like if I leave it alone, it doesn't do anything. So that's probably going to be the next video thing that I'm working on, is this single channel oscillator. The nice thing about the single channel oscillator, I can use all of the circuits that I've already developed for this oscillator, which means development time is going to be lower. It's going to be smaller, so I can probably still offer it as DIY. And it looks totally nuts. So yeah, that's everything. Thank you. Woo. All right.
When can I order?
I know, yeah. What? You'll be prototyping it.